Hello, this is what is happening on the Sun today, the 16th of July 2011. 42 years ago this day, Apollo 11 launched. So today's trivia question is, can you name the 3 members of the crew? The answer will be given at the end. The NOAA GOES X-ray plot shows that for 3 days we haven't had any significant flares. This highlights my dislike of the sunspot number as an indicator of solar activity. For as you will see, although activity is getting lower, the sunspot number keeps going up. So let's take a look at the sunspot groups and see what has been going on. Region 1245, which was temporarily renumbered Region 1253, is just a single spot. The decay in the trailing region of 1250 has continued and the trailing spots have all but disappeared. Region 1251 remains a large spot. Region 1252 is decayed to a single spot. Region 1255 was the one that I was advocating be numbered yesterday, and indeed they did number it that. And now they've numbered the new region just below it, 1256. There has been some growth in region 1254. It's developed a string of small spots trailing the leader. So all in all, we've had quite a bit of change in the sunspot regions. None of the regions have produced any rapid growth. Most of them are stable or decaying, so we would not expect any major flares from them. Consequently, solar activity has remained relatively low. Now allow me to illustrate that point about the sunspot number. Let's take a closer look at those regions in the northeast. I've produced a blow-up of this area and marked where all the different sunspots are. You can immediately see the problem. Originally NOAA thought there were just 2 regions here, then 3, then 4. But you could equally argue there's as many as 8 regions here. As for sunspot number, for each region you get 10 points and 1 point for every spot. So this group here could be interpreted as a sunspot number of 30 or in excess of 100, depending on how you count it. And we've seen problems like this before. This is why whenever I see any form of analysis using sunspot number as a basis for quantitative measurements, I take it with a huge pinch of salt. We can see the decay in the active regions from the HMI movie of the sunspot regions and also of the magnetic field. In particular, look at the developments in the northeast. For some reason, although all the data is on the web, when you try to download it, you only get half the data. So I've put it in there for completeness, but I don't think it's much use. AIA is up and running again, so we have some nice data there. In the transition region movie, one of those filaments that I was predicting lifting off in the southern hemisphere did so just on the southwest limb. And also there's a prominence on the northwest limb that looks as though it's ready to go. Here is a more detailed movie showing that a prominence eruption off the southwest limb. You can see that the prominence lifts very, very slowly initially, and then the higher loops just drift away from the sun. This is exquisitely beautiful, so I'll leave it for a few seconds for you to watch in peace and quiet. The low temperature coronal movie shows that most of the active regions are showing some sort of dynamics, but none of them are particularly impulsive or widespread. In the high temperature coronal movie, you can see that coronal hole is now at disk center, and in the next couple of days will be in the western hemisphere, and that's when it's likely to affect us. As the sun is turning faster than the Earth is orbiting the sun, the magnetic fields from the sun actually spiral outwards. So that means we're better connected to the western hemisphere than we are to the sun center, as we might intuitively expect. SOHO is still undergoing software problems apparently, but there's just enough data to see that eruption off the southwest limb. The ACE data from the last 24 hours shows that the solar wind temperatures remain constant and relatively low. The solar wind speed shown here in yellow has dropped significantly, but there was a sharp jump in its density later yesterday. NOAA 15 shows us that the auroral zone is relatively quiet and that the KP index has been varying only between 1 and 2. I'm going to introduce a couple of new quantities here that might be of use when we start getting major geomagnetic storms. First is the high energy electron flux, and the second is the greater than 100 MeV proton flux. You expect these quantities to change quite significantly if a coronal mass ejection starts interacting with our magnetosphere and allowing more of these high energy particles to enter it. So in summary then, the X-ray background is at B1, the sunspot number has risen to 90, the radio sun intensity remains at 95 solar flux units, the solar wind speed has dropped to 380 km per second, but its density has increased to 5 protons per cubic centimetre, and geospace conditions remain quiet. So my forecast for the next 24 hours is that the chance of getting C flares looks fairly poor, but the chance of getting M or X flares looks very remote indeed. The sunspot number should go lower. The chance of coronal mass ejections look very good. There's still some filaments in the south that are likely to lift off, and then we also have that one on the northwest limb. The solar wind speed will remain low for at least another 24 hours, but then should start increasing as this coronal hole starts to influence us. And the chance of getting a geomagnetic storm in the next 24 hours is quite remote. In the longer term, then, it seems to be no regions returning for the next 2 or 3 days, so we can only expect new activity from growing regions or emergence of new regions. The answer to the trivia question is the names of the Apollo 11 crew, reading from left to right, are Neil Armstrong, Mike Collins and Buzz Aldrin. That's it for today. Keep safe. Bye for now.